Good morning, students. So, in our last class, we are dealing about the amino acid structure and properties of amino acid, biological importance of amino acids. So, in today's class, we are going to take up with uh, two more properties of your amino acid, and later on we'll go with the how we are classifying the protein again based on some fibrous nature, okay, based on some fibers or based on some globular structures, so that we need to know. So now let us continue the leftover concepts of properties of your amino acids. So, and we are read that how it will act as a bitter ion, and what is the isoelectric point of your amino acids, and how it has been classified based on the structure, based on the nature, and based on the essential needs like biological importance. We are done with it. So now, optical activity. Okay, optical activity. What is by optical activity? Optical activity, we have read that in a few classes back, like that is when an plane polarized light is passed on an object, it will rotate. Okay, it will rotate on its axis. Rotate on its axis. So that is called optical activity. So when a compound or a molecule will pass by an light, that is plane polarized light, it is called as optical activity. Okay, so fine. Next, in that we have two types, that is L and D rotations. Okay, L and D rotation. So L rotation means if it is rotate towards your left, it is rotate your right. Okay, so if the molecule is rotate towards your left, towards, you can say towards an amino group, this is towards an carboxylic group. Okay, so this is called as L and D rotations in amino acid based on the plane of rotation, based on the plane of axis, or based on the rotation of axis. So this is the optical activity of your amino acid. Next you have is peptides and polypeptides. Okay, next you have peptides and polypeptides. So what do you mean by peptide? Peptide is an CONH group. So what do you mean by peptide? Peptide is an CONH group. What it will do? It's a type of bond. It's a type of bond where it connects two amino acid group. Okay, it connects two amino acid group. Peptide is a type of bond where CONH is present. It connects two amino acid by the link of CO and NH. So by knowing this, you can say this is a bond exists between carboxylic group of one amino acid and amino group of another amino acid. So I'll just write two amino acids. This is our group. Let us see it's R1. Okay. Okay, you can see them, right? So what happened? I'll just split the H2 like this. So this is R1. This is the first amino acid and this is the second one amino acid. So what it will do? It will just a connection between CO and NH. How it will connect? From this OH will remove and from NH to H will remove and it will form H2O and it will become like this. It's further. So you should write like this. If it is continuing, then the remaining thing is NH bond here OC, then again bond CR2 here NH2, then it's continuing H. So this bond is called it as peptide bond. Peptide bond. So in that peptide bond, you have many number based on the number of amino groups are joining. Okay, based on the number of amino groups are joining, you have so many types. So we are usually called it as dipeptide. Okay, dipeptide. Can anyone say what do you mean by dipeptide? Okay. Am I audible? Okay, fine. So yes, Megan, I'll repeat. Sorry, Kavya. Kavya, it is like we are connected. First, see this diagram. This is one amino acid. So you just forgot this. This is one amino acid. Here, carboxylic group is there, amino group is there, R1 and H. Okay. And now here, this is second amino acid. Carboxylic group. This one is not there. This hydrogen is not there. What I'm covering in the top, this is not there. So this is carboxylic group, R group, and H and amino group. This is carbon. Okay, fine. So you can see the presence of two amino group here. Okay, two amino groups are present. So what happened in the med? It's connected carboxylic group with your amino group. So I split like this, like NH2 instead of writing NH2, NH, write like this. So from the COH, OH will remove, from the NH2, H will remove, it will form water molecule. Okay, and it will become like this. This NH from your first amino acid and CO from your second amino acid will form a bond that is called peptide bond. NHOC or NHCO group is called it as peptide bond. NHCO group is called it as peptide bond. Okay, been able to get the point? So now I'm asking the question, in dipeptide, this is called peptide. Okay, this bond is called peptide. In dipeptide, can you just say how many amino acids are there or how many peptide bonds are there? You can derive in both the ways. So Muhammad saying two peptide. Dipeptide means two peptide. That's what I'm saying. Two peptide bond or two amino acid. What you are saying, Muhammad? Meghana, only 2 units are present. Only 2 units means, Meghana, you are saying about the amino acid number. Is it right? Then Josna, Josine, yeah, tell me. A peptide means amino acid. That dipeptide means 2 amino acid. Yes, you are right. Then Sujal, 2 amino acids bonded by peptide bond. You are right. For dipeptide, ma'am. Yeah, Meghana. What do you mean by dipeptide? Can you just tell me? In terms of peptide bond, you can say. Otherwise, in terms of amino acid also, you can say. Is called dipeptide. Yes, yes. I'll conclude it. What do you mean by dipeptide means dipeptide. Almost we are confusing with this because we are saying this is called peptide bond. So what we'll think if this bond is 2, then we are saying this is dipeptide. No, it is not right. What do you mean by dipeptide means 2 amino acids, 2 amino acid link with one peptide bond. Okay, so you should remember this. If we are specifying peptide bond, that is not peptide. That is not peptide. Peptide means your amino acid, we are calling it as peptide, a unit. The unit is said it as peptide. So what do you mean by dipeptide means? Dipeptide means it contains 2 amino acid linked with one peptide bond. You should mention one peptide bond. Dipeptide means 2 amino acids are present, but the bond is only one bond, that is peptide bond. Tripeptide means to say you have 3 amino acid linked with 2 peptide bond. Tetra, 4 amino acid. So this peptide tri means in terms of amino acid we are saying. Okay. Is it clear? Shall I move? Is it clear? So we can write so many such things. Yes, okay, fine. So we are done with the peptides. Now let us go with the polypeptides. Polypeptide. Polypeptide. So the word says polypeptide means many number of amino acids are present and it's linked with peptide bond. Okay, and it's linked with peptide bond. I'll just write this R1 represent the first amino acid like that. Okay, like this. But the thing or if you are writing your amino group in your left and carboxyl group in your right, you should continue that for all the amino acids. One like this and one more like ulta, that is not a correct thing. Okay. You should maintain one process. It will continue. Can you see this is called polypeptide? So you can see the number of peptide bonds. So how many number of amino acids is there? Less than one peptide bonds is present. Suppose here 1, 2, 3, 4, 5 amino acid is there, 4 peptide bond. 6 amino acid, 5 peptide bond. So number of amino acid less by 1, you will get number of peptide bonds. This is called polypeptide. Understand? Understood? So it can, the polypeptide may have the weight till 10,000 number. The number of amino acid can take till 10,000. Okay, the amino acid can take till 10,000. Okay, shall we move on to the proteins? No? Okay, fine. So this is the basic, that is before the studying of protein, we need to know the basic units of protein, that is amino acid. We are ready with that. So now we'll move on to the proteins. We'll move on to the proteins. So what do you mean by protein? Yes, as we study, protein is an nitrogenous compound. Nitrogenous compound. Okay, it's a nitrogenous compound found in all living organisms, found in all living system. And when amino acid cluster, the amino acid cluster will form and quaternary structures will form quaternary structures or complex structures leads to the formation of your protein. Okay, leads to the formation of your protein. So then it having the molecular weight more than 10,000, because till 10,000 you can see the presence of amino acid, but if it is crosses the 10,000 it will become an protein. So you can say in the minimal amount, in the minimal number, we can say the amino acid chain, but if it is exceeds, if it is more than it, we are saying that same chain as an protein. We are saying the same chain as an protein. Okay, so then what is the number? Then till which number you can say it's an amino acid? That number is 51. Till 51, the amino acid chain can be said it as peptides. Till 51 number, you can say the amino acid as peptides. Till 51, you can say the number of amino acid as 51. But if it exceeds, if it is crosses 51, from that we are saying it's an proteins. Till 51, it is peptides. After 51, it is amino acid. But we have one thing, that is insulin. Insulin. I think everybody might have heard this very familiar word, that is called insulin. This having the 51 amino acid, that is 31 amino acid in one chain and 20 amino acid in second chain. This is first chain contain 31 amino acid and second chain contain 20 amino acid. So the total number of amino acid present in the insulin is 51. So now tell me whether it belongs to peptide or protein. Can you tell me this insulin belongs to peptide or a protein? Think and tell me fast. Peptide. Yes, Kavya, Gokul, Srujan, you are right. It's a peptide because this insulin is said it as intermediate between peptides and protein. But because of the extracting of only one amino acid, we are considering the insulin as an peptide. It's not an protein because it will attain tertiary structure, not an quaternary structure. Okay, it will attain tertiary structure, not an quaternary structure. I'll explain that. What do you mean by tertiary, quaternary, simple, binary structures? You have lots of things. I'll explain that. No worry. So this is about your how we are classifying the peptides with your proteins. So now classifications of protein. Okay, classifications of protein. So based on the shape and structure, Okay, based on the shape and structure, you have an classifications, that is fibrous protein. Okay, fibrous proteins and globular protein. So based on the shapes and structure, you have two types of protein, that is fibrous and globular. What do you mean by fibrous? Fibrous protein is a type of protein where we can see long, thin, sorry, long thread structure. Okay, long thread-like structure. They align themselves with a parallel like a fibrous. Okay. So I'll write the structure now. It's a long thread-like structure. You can see two or more chain link with disulfide bond. Link with disulfide bond. So what do I mean by fibrous protein? It's a long thread-like structure where two or more chains are present. You can see the chains are arranged in a parallel way. Chains are arranged in a parallel way, and that chains are linked with disulfide bond or hydrogen bond. This is called disulfide bond. I'll zoom it out. This is one chain, this is second chain of amino acid. Okay, so if it is linked like this is called disulfide bond. SS, two sulfur are present, that is called disulfide bond. Yes, Sujan, muscle fiber or fibrous protein. Muscle fiber, we can say. Okay, this is called disulfide bond. So what do you mean by fibrous protein? Fibrous proteins are long thread-like structure which are arranged in a linear way. The chains are present in two or more in number, and that parallel chains are linked with disulfide bond or hydrogen bond. Okay, are you fine with it? So you should remember what do you mean by fibrous. Fibrous means you can remember the jute structure. It's straight structure. So it's present in a linear way. It's a thread-like structure. More number of chains are arranged in a parallel way, and those chains are linked with either disulfide bond or your hydrogen bond. Then next is your globular protein. Protein. Globule. How your globe is present? That is in spherical shape. That is in spherical shape. And sorry, I forgot to say one thing. Your fibrous protein, because of the fibrous nature, it is insoluble in water. You can just think and say it, right? So these proteins are insoluble in water. Your globular protein, it's spherical in shape and it is soluble in structure. Sorry, soluble in water. Soluble in water. So for the fibrous protein, we can give the example of what to say. Can you give the example for this for fibrous protein? Can you try? Sujan say almost is nearby for the example. Can you tell me which is muscle fiber? Muscle fiber. Myosin. Myosin is said as muscle fiber. Sujan, your answer is almost nearby. The muscle fiber is said to be as myosin. So myosin is the best example for your fibrous protein. For globular, you can see the presence of protein should be dissolved. So the protein is dissolving is your insulin. Insulin. So the insulin present in blood, that's why it's having the capacity of dissolving. Myosin present in your muscles, so it doesn't want to dissolve. So that's why your muscle fiber, fibrous protein are in the insoluble nature. Is it okay? So I can write this is a structure of your insulin, like globular. Myofibric, myosin is a muscle fiber, that is a fibrous protein, and insulin is a globular protein, that is in your blood, that is soluble in water. Fibrous is insoluble in water. This is spherical in shape. There is long thread-like structure. You can have the question like this, write the differences between fibrous protein and globular protein. Is it okay, Sujan? Hemoglobin. Yes, Sujan. You can give the example for hemoglobin also. For globular, you can give hemoglobin, egg albumin, insulin. You can give, no problem. For fibrous, you can give keratin, myosin. These are all insoluble. Insoluble protein you can give for fibrous, and soluble protein you can give the example for globular. Okay, shall we move on? Next, based on the composition, based on the what are the amino acids present, based on the composition of your amino acid, you have a classifications of amino acid, that is based on composition. Based on composition. So based on composition means what are the amino acids which present. Based on that, we have simple protein. Okay, we have simple protein and conjugate protein. Third one is derived protein. So based on the composition, we have simple protein, conjugate protein, and derived protein. Simple protein are the types of protein you can see the presence of alpha amino acid. Only alpha amino acid. You can see the presence of only alpha amino acid. For that, you can give the example of egg albumin. Egg albumin. So what do you mean by simple protein? Simple protein is a type of protein where it is consists of it formed only the alpha amino acids. So that alpha amino acid is present in your egg albumin. So egg albumin, we can give the best example for your simple protein. So what do you mean by conjugate protein? Conjugate protein means with your alpha amino acid, prosthetic group is present. Prosthetic group. What do you mean by prosthetic group? Prosthetic group. Whatever prosthetic group means. So see, this is the chain of your protein. So in between that, any metal or an electronegative compound. So sorry. So this is your some structure of amino acid. So in middle you have metal or any amino acid, any electronegative group that can hold entire amino acid in a fine structure, that is called prosthetic group. Whatever the group may be an metal, or that group may be an electronegative component, or that may be an electropositive component also. So okay, so among with your along with your alpha amino acid, your prosthetic group is present. That is called it as conjugate protein. So there is a best example your hemoglobin. Hemoglobin, because in hemoglobin you have iron as an prosthetic group and furfuryl ring. Do you know the structure of hemoglobin? So this is your here you have a long chains and it's connected with carboxylic groups. So this is your hemoglobin structure. So this iron is seems to be a prosthetic group. This is called furfuryl ring. Furfuryl ring, and this is called prosthetic group. So your amino acid cluster is held by your any of the groups. That's why you call it as a prosthetic group. Next, derived protein. What do you mean by derived protein? It's a simple and conjugated. So it's a combination of simple and conjugated. Derived means it should be derived from the other. So combination of simple and your conjugate protein. Okay. So when we are heating it up, it should be get hydrolyzed. It should get hydrolyzed. So you can either it may be conjugate protein or it may be simple protein, but when you are giving some temperature, when you are heating, it should hydrolyze. That is, when you are taking egg albumin, if you are heating it up, you will get hydrolyzed albumin. That is, cooked egg albumin is a best example for your derived protein. Just a second, I will take attendance. I forgot. Okay, is it clear? So simple protein means it is only contain alpha amino acids. So and conjugate protein means that conjugate protein contain alpha amino acid with prosthetic group, and derived protein means that may derived from your uh, conjugate protein or simple protein, but when you are giving heat, it should hydrolyze. It should partially hydrolyze. It should break up. That's it called derived protein. You can say that is derived from a simple, or that may be derived from your conjugate protein. The examples for simple, it's egg albumin, and for conjugate, it's hemoglobin, and for derived, it's your cooked egg albumin. Is it clear? So next class, we have structure of protein. So in that, we have 4 types of protein structure. So based on that, we are living, we are doing so many things. And nowadays, the highly trending is your protein chemistry. You can say it is a life for all. Why we are saying means without an amino acid structures, without an proteins, we are zero. We can't do anything. If we are using the pen, the coating of this pen, the structure of pen, its composition, everything should be known by protein. And whatever we are seeing the viruses, the protein coat of your viruses, we are seeing coronavirus, right? Coat we should derive, that is for protein chemistry. So we can't live without protein. So it is evergreen subject. The protein chemistry is evergreen subject, and always you have a scope with that. Scope means in terms of my words, I can say scope means that should run at any condition. So if you are going the life until our death, we have the life. So that is called protein chemistry. So you have to read, have lot to learn, but let us see how much we can possible, that much I can convey. So, and I need to tell you one more thing. Egg yolk, yeah, yes, egg yolk is different. Yolk means that yellow part. Okay, the gokul. Gokul, the egg yolk means your yellow part. Albumin means there is protein part which is white in color. So if you see the egg, you can recognize the both things. Yellow color is rich in fat, but white color is rich in protein. That's why they used to prefer eat that white part, not an yellow part. So albumin means that is white part. Yolk means yellow part. Okay, Gokul? Fine. And I need to tell you one thing. I didn't give a test for electrochemistry, right? So in next week of Saturday, I'll give electrochemistry. And you should notice one thing, and notice or not, I don't know. In yesterday's test, like Saturday test, I didn't give you any one single problem because in solid states, solutions, and electrochemistry, you have much more problems to do. So that's why what I'll do in next week, I'll give electrochemistry test, no problem. You just write the written part and the problems for all these three lessons. I'll make one test and I'll give only test for the problems or maybe test. So apart from your problems, I'll for entire electrochemistry in the next upcoming week. So only we are left with the 18th group elements, and that is so simple. In the running class or in maths class, I can give you that test of 18th group elements. So no problem. Next Saturday, you have a test on electrochemistry. Okay, because anyway, we are almost in the end point of your biomolecules. So we can finish in a week. So after that, you have a biomolecules test. So that's why we are doing it off. For the test, sorry, date next Saturday. I didn't saw the date. I think it's a 5th. I think it's 5th September. Yes, Sujan is 5th. Then did they reduce any chapter? Yeah, they told it's reducing, but we don't know, right? Uh, they told it's 35 to 40% has been reduced, but until and unless they were giving the notifications or until and unless they're giving the scheme, we can't do anything. So we don't have any other option. We need to prepare because at the peak point we can't rush and prepare. So it's better to know something rather than nothing. Okay, for the test. Yeah, that is what. Sujan, it's of I think so 5th of September, Saturday. Okay. Any doubt you can ask me or you can text me in WhatsApp. No problem, sir.